So this is my conceptual objective 1A reassessment assignment, and the directions say, for each position versus time graph, sketch the corresponding velocity versus time graph and explain why the velocity versus time graph corresponds to the position versus time graph. So for the first graph, this is the position versus time line, and then it's going to be a constant increase in slope. So the slope is directly related, the slope of position graph is directly related to the velocity graph. So the velocity graph would be this line right here. It's just going to be a constant value of whatever this slope is. So in movement wise, it starts at a negative value and it's going to end up at the origin, and then it's going to go way far past the origin at the end. So starting off, the origin is right here, and then so it starts slightly negative, and then with a constant speed it's just going to go towards the origin and then far positive, and the graph ends. And then for second graph, the position is constant. There's no slope, which means the velocity graph is just going to be 0 down here, straight across. And then, so since the position is constant, there's not any change in position, and then so the object isn't going to move, and it starts at a positive spot. So it's going to start at this positive spot and just sit there. It's not going to do anything. And then the next graph, the position versus time is the thick black line, and it starts very positive. It's almost like backwards of the first graph. So it starts very positive and then ends up at the origin and then ends up negative, and it has a constant negative slope. So the velocity versus time graph is just going to be a straight horizontal line down here. The graph couldn't really fit all of it. It's going to be a bigger magnitude, but it doesn't fit on the graph, so it's just going to be a constant velocity versus time graph. So for the movement, it's going to start really positive out here, and then it's going to move with a constant velocity until it hits the origin, and then go past the origin and go negative. So it's going to start back here way to the positive side. Positive is right, negative is going to the left. So it's going to start way positive and then head towards the origin at the constant speed, and then hit the origin and go negative, and then the graph stops. And then next graph is the blue line. So it starts at the origin, it gradually increases in the shape of a parabola, so its position is gradually increasing, and then so its velocity versus time graph is just the slope of that, so it's going to be a constant positive slope and positive constant velocity. So it starts at 0 and then ends up going in the positive direction. So starts at 0 and then it moves constant velocity, so gradually increasing. So it's just going to be as if I'm pushing it, and it's getting faster as it's going. And then the next graph, the position versus time is the blue line, and it's almost like the opposite but bigger magnitude. So it starts very positive, gradually decreases in a parabola towards the origin, and then ends up going negative. Then the graph ends. So the velocity versus time is going to be this black line. It's going to be a constant constant decrease linear in a linear line, and then it's going to hit the origin at the same spot. So this is going to start way positive and then be coming more and more negative at the same rate. So it's going to be, the movement is going to be like this. It's going to be positive, and then it's going to head towards the origin and then go off negative. So this next graph is the position versus time, is this line, parabola, and it's basically like our free fall position graphs when we did objects in free fall unit and gravity took over. So instead of doing this like linearly, I'm just gonna do exactly how we did those problems. So that's the position graph, and then so basically it would be like as if I threw this, and the origin's right here, as if I threw it and it came back up and then it came back down like that, and then it would have started at the origin actually, but whatever, it's like you throw something and it lands like that. So it's going to, the velocity is going to start positive because it's a positive slope right here, and then it's going to end up at the origin at the top where it has to change direction when you throw it in the air, and it's zero, the velocity is zero at that point, so it goes down to the origin and hits it there, and then it becomes more and more negative, and its velocity is becomes negative because of the slope when it has to come back down to the ground or the table. So that this line right here is the velocity versus time graph. And then the next graph, and then the next position versus time graph is this black one here. So it's a positive constant linear line sloping upwards. So it's increasing its position, and then its position stays constant for a slightly longer time, and then it eventually decreases to a positive, well, almost a positive slope. It's probably going to be more positive if the graph continued, but it's going to go down to the origin. So the velocity versus time graph would be this. It's going to be a constant positive value velocity for this time period from here to here, because the slope is the same and it's positive the whole time, and then it's going to go down to zero for a slightly longer time because this line's slightly longer. It's going to go to zero because that slope is zero, and then for this parabola line it's going to end up at the origin right there, and then because it almost wants to change into a positive slope, and then it's going to start off really negative and get less and less negative as at the same rate as it goes down towards the origin. So it's going to be a linear line like that, and the line is going to be linear because it is decreasing at the same rate to try and get to the origin. So the movement would look like it would start in the positive direction and then have a constant velocity until it's going to be moving to the right. So it's going to be positive, and it's going to have a constant velocity for a little bit, so it's going to be moving constant, and then it's going to stand still for about the same amount of time, and it's going to be getting closer to the origin. So after it stands still for a little bit, it's going to be headed at a linear velocity in the negative quadrant. It's going to be heading towards the origin, and it basically ends there. And then for the next position versus time graph, it starts very positive and gradually gets more and more negative so that it becomes zero at the origin, and then heads off at the same slope as it is up here. So it's going to be same slope here, same slope here. So it's going to be a linear velocity. So this line right here is going to be the velocity, so it's going to be constant. And it's going to hit the origin at the exact same spot because it's going to be 0. So then the movement is going to look like it's going to be far positive, and it's going to be a increasing linear line for velocity, and its position is going to be heading towards the origin and then away from the origin. So it's going to start positive, and then at the same speed it's going to head towards the origin and then back away from the origin. And then for the last graph, the position versus time is the more rounded one. So it's going to start at 0. It's going to have a velocity 0 at this peak down here, and then that peak. So it's going to head down, its velocity is going to head down to 0 at that point. And then its slope, the position slope, is going to get negative here until it reaches the origin position-wise. So then the slope is going to be negative at that point. This is supposed to be a little more rounded. So basically it's going to end up at the origin, and it's going to start at the origin, and every time the position hits a peak, its velocity, since the slope of the position graph is velocity, the velocity is going to be 0 at this point, and so the movement is just going to look like it's going to start at the origin. So starting at the origin, it's going to move constantly towards the positive direction. So it's going to head to the right, back and forth pretty much. So it starts at the origin, going to head over here, and then since it has to change direction, its slope's got to change position on the position graph. It's going to be 0 at this point. This is where the peaks are on the position versus time graph. And then it's going to move back towards the origin. And the first time it hits the origin is going to be at this spot. And then it's going to happen and repeat 2 more times. So it's going to be at the origin again, and then it's going to be moving in the negative direction for a little bit, and then it's going to have to change, so its velocity is going to be 0 at this point. It's going to be stopped, and then it's going to change back direction, head towards the origin. It's going to be at the origin, and it's going to keep going, and it's going to be moving in the positive direction. It's going to stop instantly at a moment, and then change direction and head back over to the origin, and then stop.